Okay, hard at work on practice problems. Actually, these are the in-class homework problems. We got people doing 219. We got 221 and 230 over there. Looking at the handout, this is the 219 one, expressing a position vector as Cartesian form and then determining magnitude and coordinate direction angles. So they're starting in right there with, they've identified A and B, and you got to do RAB, so it's going to be B minus A. So point B is defined like that, point A, and they've defined RAB.
This is the position, so it's a vector? No, it's not a vector. No.
Magnitude is 9.
Yeah.
The unit vector. Come back to them. 221. Did y'all get my email about the quiz, by the way? Did anybody not get my email about the quiz? But you got it though, right?
Sure.
Did you get my email about the quiz?
I saw it in an announcement, but I didn't know.
Yeah.
What's going on?
Yeah, quiz.
Today?
No, it's due tomorrow, like tomorrow at midnight or something.
Tomorrow at midnight.
Yeah.
I'm going out of town today, and I won't have access to my computer until.
Well, you could take it today before you go. Yeah.
After class? Okay.
Yeah.
Oh, shoot. So
That would give you the magnitude.
Yeah.
After that, you multiply it by
magnitude
the force.
So 21, you're trying to do this force as a Cartesian vector, and getting some focus here. You've defined, wait, you wrote the answer on top.
Oh.
So that's the answer. So delete that. You have to derive it.
I thought that was the part of the question.
Yeah, that's what you're supposed to get.
Okay.
I'm just confused because you know right now?
Oh, this is what I meant to write.
I didn't get that.
Yeah, you're given that it's 630 newtons, and you're giving that it's pointed between A and B, right? And so you know the process is. But what you find in there, you've subtracted A and B. That's not FAB, right? What is that? That's not a force. What are the units of A and B?
So B.
What is it called?
R?
Yeah, that's R,
Yeah, that's it.
not F.
So we do RAB of the magnitude of RAB, right?
Yeah, that gives you a unit vector, and then you multiply that times 630.
Right, okay. Yeah, just the steps.
Do you have any more?
Do I have any what? More handouts?
Yeah.
Yeah, there's a bunch right there. There's one that's stapled right there. Yep.
That makes like a sense.
So you're finding A and B, and find RAB. And David, you're engaging in this, right?
Yeah.
Okay.
I mean,
Yeah, don't let my cord get in the way. Go on the other side.
Maybe this next.
Yeah, good. So you found RAB. Okay, how is Matthew doing with 230? Oh, you've got a dot product problem. The components of the force acting parallel and perpendicular to the axis of the pole. I got a weak battery, so I'm having my cord here. I can go over here for a little bit. So how'd you start setting this one up?
So I drew my picture, and then I realized that I wanted to find F1 in terms of the XY plane because we're given it as like a projection.
Yeah, you're right. You want to find F1 prime, right?
Yeah, so I set that
Or
up.
F1 XY, yeah, that's good.
Yeah, so I found 300 pounds there is what's the XY component here. So now I'm going to set it up so that I can get an I hat, J hat, and then the K hat is just going to be just the 600 times the sine of 60 degrees.
Sure.
So we're getting up. And then I tried to define the vector here between O and A down here. I was kind of getting confused with the signs though, but since we're ending here, it's going to be final minus initial. So
Yes, it's just point A because O is the origin.
yeah.
So that's your ROA.
Yeah, so minus
Magnitude
4
is 6.
plus 4 minus
So that's your UOA right there.
yeah, so then you get the magnitude, then you can find the unit vector, so now you know what direction it's in.
Yeah. And we're supposed to find the components acting parallel and perpendicular, so you're going to have to eventually turn those into vectors. But right, you got F. You're getting F pretty
Yeah, I'm gonna
much
get F
in Cartesian, and then you're going to dot those together, which will give you magnitude, and then you'll find the parallel vector by multiplying by UOA again.
Yeah.
Good. Cool. You're good. 219. Are you getting the answer?
Yeah, we got these. And this is the unit vector.
What do I write for the formula?
So you got the RB is 9, so UAB is that. And you just took the inverse cosine of all the components of UAB to find the directions. And they all worked out, right?
We could round, but
I mean,
just to be precise.
this is what they are right here.
Yeah, well, you know, the answers to 3 digits, you would round 130, 128 to 132. Well, that looks pretty good. Then, if you're comfortable with that, you could maybe help Matthew with his. So you guys got the thing here, you got RAB.
How's it look so far?
I think we do. You guys are quick. Yeah, let's
6:30.
UAB looks good. Wait, yeah, looks good.
Don't say wait.
I know, checking the signs. And then FAB is going to be UAB times the force.
Yeah.
Oh, we got a calculator going.
Yeah.
Now, good.
Uh-oh, froze. What happened?
180 for the first one. I.
Screen froze a little bit.
Oh, we have it.
No, 180, 19.
Screen is freezing. Huh, what is up with that? Plug in power.
Since this is going that way, which is the negative x, I'll put a negative there, right?
Yeah, I can move it.
Positive y, positive alright. Cool.
So then after that, you just.
Okay.
This is just this.
And is that the answer?
Cartesian.
Cool.
So then you can do
Right?
yeah.
Yeah. Well, why don't you try another one? Why don't you guys try doing 30 too on your own? Because they're doing 30 over there. 30. If you can do this one and 30, you can pretty much everything else is going to be pretty straightforward. 30 is a dot product problem, so you can leave that up. Yeah, don't erase that. Just
I'm gonna move this, right?
oh yeah, good.
So 300 is the XY component of this force. Because it's projected onto the XY plane. So
Oh, so now it's you just right?
yeah.
The projection.
Yeah. So then.
Right?
259. 8 divided by 64. 43.
So you found F in Cartesian form. You got the magnitude of F. Unit vector and F.
So then that's the unit vector. So now, what does it want? To find the components?
Yeah.
Parallel and perpendicular. So use the dot sign, right? You don't need to find the theta though, do we?
So you need F parallel and F perpendicular
But do we need to
as
find-
vectors.
Do we need to find a?
It doesn't look like it's asking for theta.
Okay. But we don't need that to find the.
I mean, you could, knowing theta, then you know the magnitude of f parallel is just f times the cosine of theta.
Yeah.
But you know, the thing is with dot product, there's a lot of ways of getting the answer. If you really just want f parallel, then you could just take and do. Well, do you have your formula sheet?
It looks like f is equal to f.
What would be the dot product of?
The water.
What two things might you take the dot product of, and what would that give you? Remember the definition of the dot product of two vectors a and b is a times b times the cosine of theta.
Right. So you take. Well, wouldn't you just take the? You have to use the unit vector from this,
Okay.
right? And then you dot that with unit vector from this.
And that will give you a magnitude of a, magnitude of b times the cosine of theta. Both of those magnitudes would be 1, so that would just give you the cosine of theta. So what else could you dot?
Can you dot it with this? No.
You could dot it with f.
Yeah, that's
And if you dot it with f, if you dot f with UOA,
yeah.
you're going to get the magnitude of f times the magnitude of UOA, which is 1, times the cosine of theta. The magnitude of f times the cosine of theta is the magnitude of f parallel, right? F parallel to OA, right? And if you kind of, is there another color marker? How about that red one?
Yeah.
If you, what we're sort of trying to do here, and you drew this dotted line here, right? That dotted line is OA continuing on, right? Here. Yeah. This here is F, this is in the direction of OA, right?
Yeah.
And so that's what you're trying to do. You're trying to resolve F1 into something that's parallel to OA and orthogonal to OA. Now F, it's confusing because I got this projection line here, and this is the projection onto the xy plane.
Yeah.
That's not OA, that's a different direction. But there, you can break up F into something that's, and I don't know what the right thing, it's probably going to be something like this, right? You can say you're breaking it up into something like this, where this is parallel, this is like OA extending, and you're just making an F1 parallel. That's F1 parallel, and an F1 perpendicular vector, right? And the direction of F1 parallel is going to be along OA.
Right.
Whatever that is, right? It's not the same as the projection, you know, onto the XY plane. It's there, and then this is going to fill it in. So it's going to be like a tilted thing. You know, it's in 3 dimensions, so these things are kind of hard to visualize, but that's essentially what you're doing. You're breaking it up into some part that's parallel to OA and perpendicular to OA.
Yeah.
And this thing would be sort of a right angle right there. Yeah. It's really helpful to kind of have an understanding of the geometry, even though it's kind of hard to draw it.
Right. So then.
So you're gonna, yeah.
Yeah. So we take the magnet. No. Well, no, because we're dotting. Yeah.
Yeah.
So we take that vector dotted with UOA.
Yes.
Yeah.
That's going to be scalar quantity.
That's going to be a scalar quantity. That gives us the magnet. That's all I want.
That will give us. That'll give you F parallel magnitude.
Right.
But you need F parallel as a vector. So once you find F parallel magnitude, then you got to multiply that by.
Cosine?
No.
Now we have to multiply it
By
by
the unit.
Not UF.
Oh, by this.
By UOA, because it's parallel to UOA. You're
Right.
finding how much in this direction. Once you have this direction vector, you know if you know the magnitude of F parallel, you multiply it times this unit vector here, and that gives you that whole thing in Cartesian form.
Got it. Okay.
Okay.
At least we can write this all out.
Guys, questions?
Okay.
This is a complicated one, yeah. Well, there's a lot of steps.
Oh, this isn't I.
So looking at this problem, you can kind of come up with some things you can do, right? So when you get a really complicated problem like this, how do you start tackling it? Well, what are some of the things you think you're going to probably need to solve this problem?
So what we're doing,
You're going to need ROA, right? Well, that makes sense.
So
you're defining ROA.
This, which is the force Cartesian vector, and we're dotting it with this, which is the one we want, so we know what the force is like parallel to this.
That's ROA.
That's going to give us.
We don't have the force along the pole.
What's the
That's
third?
what we're trying to figure. What
right.
we're trying to find is the force parallel to the pole.
Plus, I don't know what that is. Well, this is already negative down here.
This is we're trying to find force
so
parallel.
negative, so 259.
But is that the same thing as force along?
Yes.
2/3 and 72.
Yeah, parallel is
6.
That's 36, so that's 6.
so the magnitude.
And these are
Oh yeah,
right?
these are like the
Those are what?
These are units on
Actually,
this.
they're exactly.
No, position vectors are units, so those are feet. That's units of feet.
Yeah, none of these are. Yeah, so then we just add these up.
Yeah.
I guess I'm trig nonsense.
Add it to, well, you add all these up
The unit vector.
because we're getting a magnitude.
Oh yeah.
Yeah, so that plus so that's 446, which is the answer there.
So we have we'll have the unit
Oh yeah,
vector
yeah.
along,
Projection.
And then multiply this to
so we don't have
which gives you
the F along.
parallel. Right?
You can make a triangle.
Yeah, that gives us
go
the
to the
vector.
center here.
But isn't there a way
This
to
is
like
just a
find
4 by
once you
4.
have so this is
So
this is F parallel.
Yep. Keep going. So what else? While he's doing that, what else can you guys do? What can you do with F?
I'm thinking.
First of all, you're going to have to get F in Cartesian form, right? So why don't you guys work on that?
We're trying to.
Good. I'll come back.
F parallel plus F perpendicular.
So what do you mean? 3 and 4 That's that box right there.
Can't you just
That could be the answer.
can't you just square them or something like that since they're But if you subtract this from this, you don't get 401.
So you found F dot UOA. Did you get a number?
Yeah,
446
Yeah.
pounds.
Isn't it in pounds?
Yep. And that was just taking the dot product of all those components in F.
Yeah. There's the parentheses.
And that's UOA.
Isn't there
Oh,
a?
I see what you're
Took care of the signs too? Signs all worked
Yeah,
out?
they all, yeah.
Okay. So 446 in the direction of OA.
Yeah. Isn't there a formula though where, like from this though, when you have two of these, you can find the other one?
Yeah, in vector form. So you've got that's
right.
the magnitude. So this is a you got to put arrows on top of all those. That's a vector formula, not a scalar formula.
Oh, got it. Okay.
Yeah,
So,
so-
you have to.
So you then have to take F parallel magnitude and multiply it by
Yeah. So.
yeah
So F parallel
vector.
magnitude. Well, it's the magnitude, right?
Right, but well yeah, you've already found that. So you want to do like F parallel vector now is going to be F parallel
Okay.
times.
Yeah. Right. The formula for it. Yeah.
I'm leading the witness there. Yeah.
Oh. F parallel times unit vector OA.
Yeah.
So then. Oh man.
Yeah, so you just take that and just do a bunch
Yeah.
of calculations, and then that should there's an answer there, right? So that should give you.
Well, this will give us a vector, but then we just find the magnitude of it.
Oh yeah, they're only giving you the magnitudes, huh?
Yeah, they don't want us to find the
Okay.
the Cartesian.
Well, all right,
So then as soon as
but you still got to find F perpendicular to magnitude. So knowing as a vector, you can then find a perpendicular vector, and then you can find the magnitude of that. But anyway, yeah,
We'll just do it anyway.
yeah, you're good. Okay, so how's it coming over here? You guys working on finding
So
F in Cartesian form?
60.
What's this? So I have this drawing here, or what's this green dash line?
So I know there's a way that we use
so this is
that
positive
to find the force parallel to the pole.
Not that I know. So,
No?
so actually, like the tip of this arrow isn't really located in space anywhere, is it? Do you have any coordinates for that point?
No.
You don't, right?
Oh, because it's a force.
So,
It's a force, not a segment.
yeah. So you can't really,
Can't do that.
you can't really draw
Yeah.
a vector there
Okay.
because you don't know where it's going.
Okay.
And that'll give us this. And then
But you can define F using the representation to turn that into a Cartesian vector. That's what you should be focusing on. And yeah, you did that. So it's 60 degrees to the XY plane, right? And then it's 30 degrees to the y-axis. That's what that says.
Yeah.
Oh, that's what that means.
Yeah, those are are those direction angles or projection angles?
What's up?
Can I get this thing to focus?
Is that in night mode still?
That's negative.
Pardon me?
right?
Yeah.
Is that night mode?
It is.
So yeah.
Cannot focus. Normally it's pretty good. Why is it not focusing? Focus on my hand.
So this is gonna be 1.
Focus. Oh well.
Can I see my paper?
Yeah.
Oh, sorry. What
Kind of
was it?
challenging, right? So,
127.
yep. You got an angle there. You got a right angle there, right? So what's the length of that?
And then it's minus 37.
If this is 600 and that's 60 degrees, what is the length of that?
From the 60, right? Not from the right angle.
And then it is 300.
Well, it's a right triangle, so you can use trigonometry. Trigonometry is right triangle
So then we just
trigonometry.
So is that f of x?
Adjacent
It's-
over hypotenuse.
write it out.
Well, remember, we called this f prime when I was talking about that last week.
Okay.
So you can label this f prime. What is the length of f prime?
Okay. Yeah.
600 plus 960.
Yeah.
400.
There we go.
Technically.
401. Job yet. Yeah.
That's crazy, huh?
Okay, which is
Just to restart it all over.
cosine of 60 is an easy one. What is
First
cosine of
found the
60?
projection vector. Is this vector? Or this, no, this is magnitude.
So that's the magnitude and the
Projection
x
vector.
plane. Yeah.
Should memorize cosine of 60, sine of 30.
A, and this is your O, so you find
Gonna get them over and over again.
position vector.
Yeah, cosine of 60 is a half.
for this,
1/2?
which
Yeah.
is ROA.
What's cosine of 45?
And then you find the
Two
magnitude.
over 2.
And
then
as
after
a
that, you
as a
divide
decimal, what is
the
it?
Magnitude.
0.7.
Divided this,
Yeah.
the magnitude you get to the
Something
unit
like that.
vector.
Yeah.
And then once you found that,
So what is that?
you pretty much found your vector of F
Cartesian.
So
in Cartesian
That's
by using F.
Mm-hmm. So that's f prime. Now, is that going to get you Fy? What's Fy then? If you know what f prime is, and you know that's a 30-degree angle, what's Fy?
Oh, like a projection angle.
And
Or
then
projection.
from the
Yeah.
magnitude, you found
What is
the vector
Fy?
of F.
So if you're going to draw Fy,
The molecule in the parallel direction, and then from the multiply by that. I think that makes sense. I'll change the sign.
Cosine 30.
that is right.
Because
Right, because Fy is taking this thing and projecting it now onto the, throw this thing away. Somebody.
That's good.
This guy's trash too, huh? No, that works.
That's good.
So this is Fy, right?
you're going down.
This distance right there.
Because that's really.
And this distance here is Fx, right?
Yeah, so this is that. So these are just like
'Cause
the
it's-
separate lines.
I don't know, parallel to, my axes are all screwed up, but anyway, probably should go this way. Your x-axis is kind of going like that.
So if you flip the triangle,
But this is a right angle, however it looks on my drawing.
Okay.
but
Well, yeah.
And this is 30 degrees, and you figured out that this is 300, right? That's the hypotenuse of a right triangle. So you can use trig again to find out what fx and
yeah,
fy
that's
is.
why.
It's like from here, right here. It's like from saying.
that's going to give you
down.
fx.
Exactly.
Well, I'll give you both fx and fy, right? Fy is 300 times what?
And then.
Looking at that triangle there.
It's like this.
Yeah, it's super.
So this is like laying down, right?
Yeah, it's a triangle laying down. Because this is, you want the x component, so you're not going to take this one. Because that's the y. That's going this one.
Yeah.
This one.
Yeah. You want the, it's actually going to be the short one right here.
Yeah.
So this is x. Yeah. So
And then this is Y.
it's hard to see it though. It's like
Cosine 30, right?
Yep. Now pay attention to the sign too, because think about whether those each of those components, are they going in the positive
f prime. Like,
direction of their axis or the
And-
negative
What do you mean, like
direction?
the sign, not like the sign?
It's sign because it's
SIGN.
it's going up.
Mm-hmm. Yeah. What is the SIGN of those components? Or what should it be? According to the visual,
For the K.
is the y component going in the positive y direction?
Sign, yeah.
Yeah.
Because that's
Is
what's
the x
pointing up
component
here.
going in the
It's
positive x
opposite-
direction?
Opposite over Jason.
Okay,
Oh,
so then you have to put SIGNs in front of those numbers
Unless they were
to make them
decimal?
compatible to
For the
the,
decimal? Or
what
for-
decimal?
Okay, so you want this one because this is.
I don't see a decimal there.
The Y.
Yep.
Oh yeah, the X.
Well, these are, when you get a value here, that's going to be a number.
Okay.
And you have to make sure that number is in agreement with reality. Is that number supposed to be positive or negative?
Positive. Take a quick pick of this.
This one.
Well,
Standard sine of 30.
positive.
For Fy, what about Fx?
It looks like it's in the negative
Why? How do you know?
because it's going like that.
Yeah, because it's going that
If
way.
it was going like that.
If it's going that way, that would be
so if
positive.
Y was,
Yeah, if the vector was like going that way or this way,
but I mean,
then the x component could be positive.
I mean, I get it, but like, how do you know? There's no arrows on the vectors.
Well, there's no arrows, but there's a whole bunch of cues, right? And these are the graphical cues you got to look at, right? When you look at this drawing, focus finally. When you look at this drawing, they've drawn the projection onto the horizontal plane, which is kind of like that's going between the positive y-axis and the negative x-axis, right? Where that line is going, right?
The diagonal line.
Yeah, this diagonal line on the base
Mm-hmm.
is pointing, going in positive y, but negative x, right? That's what that's telling you.
Okay.
If that projection line base was going that way,
Yeah.
starts at the origin.
then both y and x would be positive, right? If it was going this way, then they would both be negative.
Would it change it?
Oh no,
if-
x would be negative. X would be positive, and y would
Would
be
it
negative.
change if the
Lost focus.
right angle was on the other side? Would that matter? Like if that triangle was like flipped. Like a
Maybe
mirror?
you'd like to see a whole bunch of ones, and we can kind of talk about that, right? We could draw a whole bunch of these things, right, real fast. Because, this stuff, you don't want this to hang you up, right? If the vector's kind of going this way, and you can draw this projection here, and you've got this is sort of what we're given, and this is a little stupid because let's make the axis go this way.
Final minus initial, right?
Then this has to kind of go parallel to that, and it kind of goes like that, right? And here fx is negative, and fy is positive, right?
Yeah.
But if the arrow, if they had the arrow going like this, and they drew it, where the projection is kind of coming down here, and they've got this box kind of going like that, right?
Why you chose?
I think my
You with
question.
me visually? We're looking at these cues though, and you're saying, well, okay, this means fx is greater than 0, right? Because we're going in the positive x-axis, right? But this says fy is less than 0 because we're going opposite the orientation of the y-axis, right? Does that answer your question?
Yeah, I guess my question was more like,
Can you use the
would
cosine inverse of
would the
I,
force
J,
given
K
ever like point down, or would it ever
individually
like
together?
end at the origin?
every
Yeah.
At the origin.
It would.
every
Yeah.
direction?
It will.
Okay.
Yeah, it'll do all sorts of things, right?
So
They may give you a force that looks like this.
yeah.
Oh yeah, you can use the unit vector.
They may give you a force that does something
It's
like
pretty
that.
much linear vector as soon as you
And they may give you these, these
Yeah,
projections too. And you have to realize, oh yeah, all those components are pushing into the origin, not pulling away from it. You got to always apply a lot of visual, processing to make sure you get the interpretation
Yeah.
right. That's a really big part of this.
Yeah.
So
Wait, what's the other way?
You just plug in like -6, 9, I guess.
Yeah.
It's the difference.
How'd you guys end up doing?
Oh, you're gonna simplify it?
Did it work okay?
Yeah.
You got it all? How'd you get F perpendicular? Well, you got F parallel as a vector, which wasn't required, but you got it anyway. That's good. And then from there, you found F perpendicular as a vector
This equation.
by subtracting, yes, with this nice vector equation. Very good, very helpful. And giving you another vector and then finding the magnitude of that, which gives you 401 pounds. Now, there is another way of doing these, right? And that's,
So since you said
it's
that
nice to know all the different ways.
you don't need this vector, so then if you don't need it, how
I don't know. The way
possibly
the way this question was worded, if I saw this on a test, it says determine the components.
okay.
To me, that means vector components, and so I would have wanted that. If it said determine the magnitude of the components of the force acting along it, then that would mean what they gave you, which is these magnitudes.
So no matter what,
I'll have to be really clear when I ask for something, what are the Cartesian components, of these forces or whatever.
so you pretty much still have to get these, no matter what.
But you don't actually. No, there is another way with the dot product. That's the cool thing about the dot product, right? Because you actually notice you did find. come and hold this piece of paper. It's in the camera. My camera. You did find UF, and you did find UOA, right? And remember, if you had we were talking about, well, what if we just dotted that, right? So if you took the dot product of UF with UOA, that would equal what? 1 times 1 times the cosine of theta.
Yeah.
Well, that angle theta is the angle to the parallel projection
Of
of F parallel to OA. So if you took UF dot UOA and took the inverse cosine of that, then you would say theta is the inverse cosine of UF dotted with UOA. Oops.
cosine of 1 is
Huh?
Isn't that just 1 though?
No, this is a dot product, so it has, wait, what?
Yeah, the size of the thing is 1, right?
Yeah.
Wait a second. No, wait.
Yeah.
UF dotted with UOA. It's remember, the dot product of any two vectors is the product of the magnitudes times the cosine of the angle between them, right? So if they were 90 degrees apart, if UF and UOA were 90 degrees apart, what would the dot product tell you? This was UOA, and this was UF, and this was 90 degrees. What would the dot product give you?
0?
Yeah. It doesn't give you 1. It gives you the cosine of theta,
Yeah,
right?
because we're using this right.
Because we know that I dot J, I dot J equals 0. Because that angle between them, you have to take the cosine of that thing, right? So this gives you a number between 0 and 1, which you're going to take the inverse cosine of and find theta.
Oh.
Once you know theta, then you don't need to calculate these. If you don't need the Cartesian components, you could just say, well, then F parallel magnitude is just 600, the magnitude of F, times the cosine of theta.
Oh,
And
and that would just
F
give you-
perpendicular magnitude is just 600 times the sine of theta.
Damn.
So that's another way of doing it. It's a little bit easier that way, too.
Faster too.
Why don't you try that and see if it works?
All right.
It's kind of a fun thing to kind of learn a little bit more about these. So take the dot product of it. You could probably squeeze them in maybe here or wherever. So you want to take the inverse cosine of the dot product of those things, right? So try to squeeze it in there if you can. You might have to erase some of this stuff too. We'll come back to you guys. How's it coming along here?
We're trying to see if this is what we do next.
So we're gonna take 0.25 times
Mm-hmm. So you found that fx is 300 sine 30, so it's minus 150. Fy is 300 cosine of 30, so 259. And fz is 600 times the sine of 60, which is 519. Okay.
Because he said probably dotting these.
yeah.
So that is your f vector. Okay,
So
good.
that times.
That agrees with what they got? That's good.
What are we doing? Okay, so we're adding them, right? Yeah, so plus
Okay.
3.
Oh, I am running out of battery. Let me plug this thing in here.
So now we can find the magnitude of that. We can find a unit vector by putting this force over the magnitude.
9%
So we
available.
get point.
For what?
So we take this and we put it over the magnitude of that, and then we get a unit vector.
That'll give you a unit vector.
How are we going to use the unit vector though?
How are you going to use the unit vector? Good question.
Well, it's already right there.
Am I helping you guys out?
In a different direction.
So what are you trying to get?
We're trying to get the force parallel to
The OA thing, right? And you found UOA, which is the direction of that pole, and you found F.
Whoa, so we take
And what does the dot product give you? When you take the dot product of two vectors, what do you
So we
get?
have to take the dot product of that and this.
So we're gonna take 600.
And that'll give you what?
This gives you,
The dot product of UOA and F is going to give you what?
what? I got this.
It's going to give you the magnitude of F times the magnitude of UOA, which is 1, times
No.
cosine of,
no, we could find the, remember we first could find the parallel, and then sine.
think back 24 hours ago at this time. What were we doing? Dot product. A times B times cosine of theta. What's theta? Guys, help them out. You guys can help them out. Did you guys get it? Did it work? So we're gonna, okay, all right. Well, I think they need an ambassador here to help them.
Is theta the angle from the XY plane to OA?
No.
No.
When you have two vectors and you take the dot product of two vectors. Right, let me ask you this. What's the dot product of I and j? What's I dot j?
The angle between these two?
0.
Would that be theta?
So what is that? The angle between what? Between the two vectors, right? Yeah, the angle between OA, like if you extend OA out here,
Yeah.
and this vector f, theta is the angle between those two vectors.
Oh.
So it'd
Okay.
be like
Yeah, 0.77.
this
0.744.
angle.
Yep, that's that angle right there. Yep, call that theta. And if you know what theta is, then the magnitude of f times the cosine of theta is the magnitude of the parallel projection of f onto OA.
So we just need to find that angle.
Yeah, well, you can find that angle, but
And now,
Let's find out.
that is it. So in other words,
That's what we want.
if the dot product of two vectors a and b is a magnitude of a magnitude of b times the cosine of theta, and you take the dot product of f,
got a
Cartesian,
46.
Yeah.
and you OA,
Now,
Cartesian,
so do the sine.
you get the magnitude of f, magnitude of UOA, which is 1, cosine of theta. So you're getting f, the result is going to be f cosine of theta. What is that? What is f cosine of theta?
401.
What does that mean, though? Is that compared to what we're looking for? What are we trying to find?
That is so much simpler. to
We're
do.
trying
That's
to
a lot easier.
find
But I feel like you
what's
just really need a
parallel
right
between
that
the two.
equation down.
Yeah.
Yeah, and what is f cosine of theta?
That's what is that called?
Oh, wait, let me just.
Did you guys get it? Did it work?
Yeah, it worked out.
See? Kind of cool, right?
I remember it.
I can't go over there because I'm out of battery, but you took the dot product of UF and UOA,
Yeah.
which is 0.744. Inverse cosine of that is, what was it, 41.9?
1.9.
41.9 degrees. And the magnitude of f, that's not f parallel, right? Good, thank you. It's the magnitude of f times the cosine of 41.9.
Yeah.
Yeah, I saw that. I was like, what?
So it'd be F parallel is equal to.
Yeah.
Yeah, is that 446? And f, yes, good. Great. Now, can you guys, in 2 minutes, help them with theirs?
I think I know what.
So they've figured out f and UOA, and they're trying to figure out what to do next. So you guys help them out.
Wait, so you guys got this, and you got UOA.
So, you could find we know what the magnitude of f is. So you could find the unit vector, like UF.
Yeah.
So,
I thought that's what we were gonna do.
because once you have that, then you can use the dot product to find,
Yeah.
you can use the shortcut route. We did the long way, but you can use the shortcut route to find the parallel and perpendicular.
So
Don't show them the shortcut route. Show them the way you did it.
Long way. But you'll still need to find it. You'll still need to find a FU or UF if you're gonna go the long way too.
I thought we told you that's what we were gonna do.
No, you don't need to find UF because you didn't, right? You took over there. What'd you do? You took
Also, then you
you took the dot product of f and UOA, right? Where you got that star there?
Yeah, we
You
don't
forgot already? Tell them. How'd you do it?
So then you multiply this by that.
Dot product.
Yeah.
Dot product.
And what does that give you?
That's what I said we were gonna do.
But I asked you, what does that give you, and you couldn't tell me. What does that give you? That's the important thing. Why? What are you gonna get out of
I don't know,
that?
I haven't done it yet. Scalar?
Well, no. You guys tell them. What does that give them when they do the dot
So
product
that'll
of
give
f?
you the magnitude of the force in the perpendicular parallel to the.
Okay.
Can you explain why?
The unit vector is pointing in that direction.
Yeah. Okay.
So then multiplying it by,
Dotting.
dotting it by this force would give you the magnitude along that direction. Okay. And since it's unit vector on the parallel direction, it makes sense that it's something to it.
I don't know if that was. Does everyone agree with that? Does this one work? Let's see.
Yeah, I think that is good.
So there was this drawing that we had of, again, any two vectors in space, right? Here's a vector A, here's a vector B. And suppose we're trying to get the amount of A that's kind of going in the direction of B, right? So this is like A parallel, right? Parallel to what?
B to B.
B, right? The amount of A that's parallel to B, and then this thing here would be the amount of A that's perpendicular to B, right?
Yeah.
Okay, and you would imagine there's some angle theta between them, right? That's pretty clear, right? Now what the dot product says is A dot B is going to give you the product of the magnitudes A times B times the cosine of theta.
Yeah.
Right? Okay, that's the important thing. That's what dot product gives you. It's very cool. Okay. Well, how does that relate to what we want? Well, what we want, if we want to find A parallel, right? What we want here is just if this is if this forms an angle theta and this is a right angle here, right? We have another right triangle here, right? That's trig. Got a right triangle that you can apply trig to. And so A parallel to B is going to equal, just what you know about trig, since we've been doing this so far, in just terms of what you see right here, how would we find the size of this thing? Cosine of what?
Theta.
Theta times what?
Times B.
What's the hypotenuse of this triangle that I just drew here? It's A, right?
Right.
That's the hypotenuse. That's the adjacent. You always got to look at those things. The trig stuff is really killing you guys. So you're going to have to really drill yourself on those things. Really. So that's going to be, what we want is A times the cosine of theta, right? That's going to give us the size of A parallel. Well, the dot product is going to give us A times B times the cosine of theta. Well, that's not exactly what we want. How do we make this more like what we want? We want A cosine theta. We got AB cosine theta. How do we take the dot product and turn it into A cosine theta? The magnitude of B, right? Mm-hmm. And then you've got basically 1 here, right? So if you took, so in other words, if you divide this by B, you got B over B there. Well, if instead of doing it with B, you did it with U sub B, right? So suppose you just took a unit vector in the B direction, right? So what would A dot U sub B equal? Right, that U sub B going in this direction of B, A dot U sub B is going to be magnitude of A, yeah, magnitude of B, which is 1, right, times the cosine of theta. Oops, that's exactly what we're trying to find. So that's why you take F and dot it with UOA, and that'll tell you how much of F is oriented along the axis, the line of UOA, of the line of OA. Okay, super, super important and really challenging, right? Because there's a lot of stuff flying around there, right? But in these formulas, you can kind of play with them a lot of different ways. A lot of ways to get the same answer. They had another way of getting the same answer, but this, I think, is the more more logical approach. You should kind of familiarize yourself with that. If you want to watch the video, you can see the other way, or they can tell you the other way before you guys go.
Use the A dotted with UB to find theta.
No, this is finding A cosine of theta. This is finding what? That's the magnitude of A parallel.
But we have A.
Which is, so magnitude of A parallel is this.
We have A, but we're asked to find how much of A is parallel to B. If you were going to break up A into 2 vectors, one parallel and one perpendicular, that when you add them together are going to give you A. We're asked to find how much of A is parallel to B and how much of A would be perpendicular to B. Because it could be that the 2 vectors are really close together, right?
Right.
It could be like that, in which case A and B, pretty much 90% of A is parallel to B, right? And just a tiny bit is perpendicular, right? Or they could be like this, where you say, well, there's nothing. The amount of A that's parallel to B is 0, and it's all perpendicular to B. Yeah. We're trying to find that kind of stuff out. Yeah, and you got to practice this. But you did it now, and you've done it once, and that means when you do some other ones in the homework, you'll be able to do those. You're not going to be stuck. If you can do these practice problems, these in-class problems, then the rest of the assigned problems should be relatively straightforward. Yeah, but they may ask you to tweak it around a little bit, but that's the basic idea.
Was something.
Yeah, so so you guys are all going away, right? So I think I will make the homework due Monday night instead of Sunday night, because you'll be back by then.
Okay.
And then
And then it's due in hand.
the quiz is due tomorrow night. I think it would be just good to get that quiz out of the way, because it's
tomorrow night?
it's due tomorrow night. You can take it right now if you want to. It's online,
So is it?
but it's all, you can't talk to each other about
It's
it.
like one question, you said,
Yeah,
and it's like not conceptual.
it's computational. Yeah, you got to find something
It's like this.
like something like this, only simpler.
How is it turning? You like take a picture of your work and then.
You're going to type in your formulas online. And you're going to just write what you do to solve it and then what the answer is. If you want to take a photo and upload it, I think there might be a way to do that too.
Okay.
Mhm.
But I think I'll just wait to do that. I can do it on my phone, right?
The whole quiz?
I mean, like not actually like do it on my phone, but like do it separately and then type it in.
I think so. It could, but it'd probably be easier. You want to just do the quiz on paper? I could just print out a quiz for you and do it right now if you want. Yeah.
Would there be like symbols on the quiz that we could put?
If there's a alpha symbol, you can type ALPHA.
Oh, so literally, right? Okay.
Yeah. THETA. You can do all that.
Yeah. Beta.
Yeah.
Gamma.
I know.
To be specific to like, it has to be written exactly like this.
It's an essay question, so I'll be evaluating your response.
So it's not like just.
So you can get partial credit. The
Okay.
more you show me, the more partial credit you can get. If you just show me a wrong answer, you're not going to get a lot of partial credit.
Okay.
Yeah, I was looking at my calculus notes,
Uh-huh.
and that's like exactly what we were doing.
Yeah, that's exactly it.
Yeah.
And you do all that, and you have a clue what you're doing that for in calculus, right? I think you have a better sense of why you're doing it
Yeah, it's kind of just like
in statics.
Yeah, just
All right.
plug it in.
There's a certain element of that, but you should always be
Yeah.
aware of what the implications of these things are.
Conceptual.
Yeah, it's going to help you a lot more conceptually with all these things. It'll probably improve your calculus grade too.
Yeah.
Cool, thank you.
Is the homework due in class?
Tuesday. Yeah.
I work until 9:30. I'm down to study after.
Yeah.
I mean, like, if you're tired.
I'm not good.